Good morning all. Write down your enrollment number in checkbox. Okay, so yesterday we have discussed this rooted tree and root. So rooted tree is a tree in which one vertex is called root, is distinct from all other vertex of a tree, and root is placed on the top. So uh, like okay, so I show you here. If you see here graph, then we call it v1 is a root, as which is placed at a top. Okay, now level of vertex. So level of vertex is a number of edges along the path from the root of a tree. So this uh, vertex v1, which I can say that at level 0. Now this v2 and v3, uh, in which we have uh, one edges here from v1 to v2 and v1 to v3. So this is at level 1. Now this v4 and v5 and v6 and v7, which are at level 2, as they have uh, two edges at that level. Okay, so this is v1 at level 0, v2 at level 1, this v2 and v3 at level 1, this v4, v5, v6, v7 at level 3, and this v8 at this at level 2 and v8 at level 3. Okay, so these things which we have already discussed: level of vertex and root. Now binary tree. So a rooted tree is called a binary tree if the out degree of every node is at most 2. Okay, out degree of every node is at most 2. Like here, see the degree of v1, which we have 2, degree of v2, which again we have 2, degree of v3, which we have 2, degree of v7, which we have 1. Okay, and degree of sorry, degree of 7, which we have also 2 here, but degree of 8, which we have 1, degree of v6 1, v5 1, and v4 1. So at most 2. So this is called a binary tree. Okay, ज़्यादा से ज़्यादा दो मतलब डिग्री हो सकती है. तो नोड लेफ्ट ऑफ द रूट इज कॉल्ड ए लेफ्ट चाइल्ड. यहाँ पे ये v2 को हम लेफ्ट चाइल्ड कहेंगे, एंड दिस so v2 is a left child of v1 and v3 is a left child of v1. So v1 is parent, v2 is left child, v3 is right child. Okay. Similar manner, this v2, which is a parent of v4 and v5, and v3 is a parent of v6 and v7. Okay, so this v4 is a left child of v2 and v5 is a left child of right child of v2, and this v6 is a left child of v3 and v7 is a right child of v3. Okay, and these are the siblings. We call this v4, v5, v6, v7. We can say that all are siblings. Now m-array tree. A rooted tree is called m-array tree if every internal vertices have at most m children. So out of the out degree of every node is at most m. Now at most m children, it means this binary tree is a two array tree as according to the definitions of binary tree, which have at most two children. Okay. Now, so what we can say about this two array tree, binary tree, which is also a three array, which is also a four array, which is also a five array, as see. Yeah, according to definitions of M array tree, which have at most uh, M children, it means if you have at most two children, which is also satisfy this condition. So every binary tree is also M array tree. Okay. Now full or complete M array tree, it means which have every internal vertex has exactly M children. Okay, then we call it full or M array tree. So other than pendant vertices are called internal vertices first of all. Okay, and pendant vertices, it means all vertices which have a degree 1. And so yeah, in a tree, if you look at, then this V4, V5, V6 and V8 are pendant vertices. Okay. Now full or complete binary tree, it means every internal vertex has exactly true children. Then we call it full or complete binary tree. Okay, this uh, every internal vertex here, internal vertex is V3 and V2 and V3. So which contain exactly two children. So this is a full and complete binary tree. Okay. So this this V1, which also contain exactly two children. So this V1, V2, V3, we call it a internal vertices. In this V4, V5, V6, V7 are pendant vertices. These are the properties. The number of vertices in full binary tree is always odd. Okay, and in any binary tree on n vertices, the number of pendant vertices is equal to n plus 1 by 2. The number of internal vertices in binary tree is n minus 1 by 2, and all leaves also pendant vertices is also called leaves in tree. Okay, so all leaves are at the same level in a complete binary tree. Okay. So if you have a complete or full binary tree, then all leaves are at the same. So all pendant vertices are at same level. Now traversing of a binary tree is a process of visiting each vertices of a binary tree in a systematic order. So there are three standard traversal of a binary tree, differentiated by the order in which the root and subtree of binary tree are visited. So here, these three are the traversal. Like first one is pre-order traversal, and second one is in-order traversal, and third is post-order traversal. So this pre-order traversal, it means like we here. Visiting the vertex from node to left and right. So node, it means here you can take as a parent, and left, this L represent as a left child, and right represent R is represent as a right child. So we are visiting in this order, N, L, R. Okay, from N it means parents, so parents to left child to right child. And in order traversal, we have LNR. So left child, then parents, and then right child. And post order traversal, left child, right child, and then parents. So these are three order of a traversal here in a binary tree. So first, free order traversal. So is defined as, like, first you have to visit the root, which means parents, and then traverse the left subtree in a pre-order, and traverse the right subtree in pre-order. And see here, if you have grabbed this, then first you have to visit the root. Root, it means A here. Okay, and then left subtree here. So in left subtree, uh, we have again here. So see, there is no another. Now if you consider this as a parents B, then we haven't here any left tree. So suppose if you have from here B to G, then our order will start from G to okay, like A to B, and then B to G, G to D. But now here we haven't any left child. Okay, for B. So now it's our order according to this pre-order. First we get here A, and then left child we have B. Now here we haven't any left child, so we are not looking at that. Now for B to D as a right subtree, and similar manner here again, if I want to visit, then first I have to take the root C and then E and F. So what I get order here is A, B, D, then C, E, F. First root, then left child, right child. Okay, and you have to start from here, from the top. Okay, so this is the pre-order traverser. Now in order traverser. So in order traversers, it means traverse in order from first you have to visit the left subtree, then you have to visit the root, and traverse in order the right subtree. So from left and then root and then right subtree. So here if you see that we haven't any left subtree of B. Suppose if you have G here, then first you have to visit G and then B and then right subtree T. But we haven't this left, so first we visit root. So root here for B, then D and A. Again the left subtree E, then C and F. So in this manner I get the order C: B, D, A, E, C, F. Okay, so this is in order traverser. I hope everyone clear this. Now post order traverser. So first we have to visit the left subtree in post order, then right subtree, and then root. Okay. So now left subtree. So here for A we have left subtree is B. And B we haven't any left subtree. So first we visit the right subtree. So this is D, and then visit the root. So D to B. Now then this is the left subtree. So we have to visit the right subtree, and in right subtree first we have to visit the left subtree E, then F, C, and at the end I get A. Okay, at the end I get A. So here root of a tree is always you get that at the end in post order traverser, and you can see that this D, B, and here E, C, F. Okay, E, C, F. So you have to remember these things for traversing. When you traversing, you want to follow this order: pre-order, in order, or post order. Then NR, NLR, LNR, and LRN. Okay, N represents parents here, node. So NLR. First in pre-order, first you have to visit the node, and then left child, right child. In order, first you have to visit the left child, then node, then right child. In post order, you have to visit the first left child, right child, and then parents. An algorithm when pre-order and in-order traversal of a given tree are given. So first you have to find a root of a tree from the pre-order by choosing its first vertex. As we know that in a pre-order we have start with first from root. So if you have given pre-order and in-order, then we already know that first we start with the root. So first element which is over root of a tree. So we can plot at root as a top of the tree. Now once you get this root from pre-order, and you see in order as if you look at this or in order or order is like L and R, L and R. So your parents node or root which are in the middle of it. So in both the side you get a left child, and on left side you get left child, and on our right side you get right child. So here find the node for the left subtree of T from the in order. Then left child of the root is the first node in the pre-order traversal of the left child, and plot this left child. Okay, and then likewise in step 2, find the node in the right subtree from the in order traversal, and the right child is the first node in the pre-order traversal of the right subtree. Plot the right child. So in this process 2 and 3 you have to repeat it, and you in this way you can find out the binary tree. Okay, so suppose like here we have given this pre-order and in order. So first of all, pre-order you have to remember this we have start with root. So N L R, these are the order for pre-order, N L R, and in order we have L N R. Okay, so like see uh, from this uh, you get first in pre-order, first this vertices is always represent a root of a tree. So this A which represent the root of a tree. Okay, now if you look at in order, then this DBGA which are in the left side of A, and CHFI which are the right side of A. So this element DBGA which are in the left subtree, okay, we get. But now from this DBGE, which element we get first here, which we want to find out. So which we get from the pre-order is B, uh, which is your first here left child of A. Okay, and once you get this B, now you have to look at here. On B we have right left side we have D. So for a B, first left child is D. Okay, here I get this is D, and uh, if you look at here D, uh, so yeah, now E is the left child of D. Okay, E is the left child of uh, sorry, here, yeah, D first we, yeah, so D is the root, then E is the left child of, here we get E, and from if in order this G, which is on the uh, yeah, so what I get this is okay, first we have right here A root, then from this we get this DBGA which are on the, which are the part of left subtree, but from pre-order we can say that here B which is the okay. So now this G and E which are the in sorry, this here we don't get this G. I have to erase this. In order G and E which are on right side of B. So this here I get, now I have to find out what we get here, G or E. Okay, so this is which I can say that from the left and then right. So this is my E. Okay, and then G is on the left of E, in order. So I get here left child as a G. Okay, and now see the CHFI which are on the right side of A. Now the in so I can say that here this C, which is over right child here. So is if we consider it roots, then F is left child F. Okay. Now in uh, this in order, uh, there is a H which is on left of F and I is on right of F. So I get in this manner H and I. Okay, let us, yeah. So sorry, here I have made a mistake. C again we have a yeah, this F which are C, and then uh, this F we get here as a right child. Okay, F we get as a right child. So there is a correction here. Yeah, F is a right child, and then okay, fine. So I make a mistake for this. This is my C here. Okay, and then you get F right child, and for F here H and I, H left child and I as a right child. Okay, so there is a correction here. Okay, so now I think you get the idea how to find out this tree from binary tree from the pre-order and in order. So if you have given a pre-order and in order, then first you have to look at here uh, the element, first element of pre-order, and which is the root of a binary tree, and then you look at to here in order. Now these are all elements, all vertices which are the left side of A, and these are the right side of A. Now from that you have to find out the left side of A. So here you get this B which represents the left child of A. Now B here, if you look in order, then in left side of B we have D. So this D is a left child of B, and G. Now in right side we have G and E. Okay, so from this again we have to find out the eligible candidate. Okay, so here G uh, is on right side of E. So as a pre-order, first we get uh, root, and then left child, and then right child. So if I consider this E as a root here, okay, then parents, then G is like left child. Okay, but now C is not right child of E because C is right on A here. Okay, C H F I right on A. So which are the uh, so from that we have to find out the right child of A. Okay, so C. So for that we look at here uh, this C and this A, B, D, E, G, which are on the right side of C. But all this which we have covered in here, P, D, E, G. So this F, H, I, which are on the right side of C, and C according to pre-order. First we have uh, as a node, and then left child, and then right child. Okay, but so here I just look at C as a node. Now from this in order, uh, 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 here we have HFI, and so from that again I have to find out this right child and left child. So F is in the on F we have a left side H and right side I. So I get this H and I, and this on the right, yeah. So here in pre-order node, and then we have FHI, and for that we look at here. Okay, which one is so F is in the middle of H and I. So F is node for that, and this is the left and right child here. So algorithm when in order and post order traversal of tree are given. Okay. Previously we have discussed for pre-order and in order. Now here we have in order and post order. So find the root of a binary tree T by taking last node of post order. As we know that in post order, the last node which represents the root of a binary tree. And find the node in right subtree by using in order traversal and which are on the right of the root node. Okay, and the right child of the root is taken as a last vertex of the right subtree in the post order traversal and plot the right child. Okay, and repeating likewise, step 2, the find the node in the left subtree of T in order traversal, and the left side of the root is taken as the left vertex of left subtree in post order traversal and plot left child of it. And then repeating this step 2 and 3. Uh, so every vertex is visited in post order, and finally we get the binary tree. So here, like suppose you have given in order and post order. So first the this last element which represent the root of uh, a binary tree. Okay. Now if you look in order, then A is here. So in left side we have D, B, E, and in right side all these are the eligible candidate for in which you have to find out the right child, and from that you have to find out first left child of A. So now if you look at here, then yes, I show you here like this is A is your first root. Now so in DB which are on the uh, left side of A, so from that again in order uh, see D is on left side of B and E is on right side of B, so this we get D as a left child of B and E as a right child of B. And here these are the eligible candidate. Now see in which uh, we have a F on right side of C, and all these are on left side of C. So sorry, F is the left side of C and all these are the right side. So F is the left child first of all. Now again from that you want to find out the left child and right child. Okay, so you have to find out first right child of C. Okay, so like you have L, J, M, H, K, G, I, but now from that you want to find out the right child. So you can see that as the third last here element we have C. So at G, okay, like here is first the A which represents the root. Now second one here which is the root of a right child, and again uh, this is the uh, G is a root of uh, third level here as a second level uh, node here. Okay, so right child of C which we get G. Now you have to look at G. So in G, in right side we have only I. So I is the right child of G. Okay, and now on the left hand side these are so many eligible candidates, but in which these are the L, J, M, H, K. Okay, which are the eligible, in which I have to find out the left child, which one is the left child of G. So for that, okay, like we have L, J, M, H, K. Then uh, you have look at here. I we have already here right child. Now H. So H is the left child of G. Okay, now you have to look at here H. So on H we have a left side L, J. Okay, L, J and LJM, and right side we have KGI, but G and I we have already used. So this K which is the right child of H. Okay, K is the right child of H. Now we have these three elements. Now again you have to look at here this H, K we have done. Now J. So J is the left child of H. Okay, J is left child of H. Now again you have to look at here J. Then on left side we have L and right side M. So left child of J is L and right side of J is M. Okay. So in this manner you can find out the binary from the in order and post order if you have given. Now, how to convert any M array tree in a or we can say the general tree to binary tree. As we know that every binary tree is an M array tree. So if you have given any M array tree, then we can also convert into a binary uh, tree here. Okay. So these are the algorithm for to convert any M array tree into a binary tree. First, start from the root of the general tree, and uh, uh, root of a general tree will be the root of a binary tree. Okay. So find the leftmost child of a parent node. Okay, and connect sibling of each node from left to right. Okay, and delete all link from the node to its uh, child. Okay, and repeating the same process for all the nodes. Okay, so we have to start like suppose you have given any M array or general tree, and from that if we want to find out the binary tree, so such thing we are going to be process right now. Like suppose we have given this is a uh, M array tree or general tree. Okay, this is not a binary tree. You can see that as VR has a uh, fourth child here. Okay, so which is greater than 2. So this is not a binary tree. But now I want to convert this tree into a binary tree. So first I have to start with this VR. Okay, VR is our root tree, root here. Okay, so I start with this VR. Okay, VR vertex. Now, as our according to our step, first we have to find out the left child, leftmost here V1. We have V1 is our leftmost child. Okay, this V1. Now, you have to look at this sibling. This V2, V3, V4 all are the sibling of V1. Okay, so first sibling here V2, which is the right child of V1. So in a binary tree, which is the right child of V1. Okay, so we call it V2. Again, if you look at here on left side of V2, V3 is sibling. So V3 is the right child of V2 in a binary tree. So again, we get a here V3. Okay, in binary tree here I get V3 right child, and V4 is also a sibling, so which is also a right child of V3. So I get this is a V4. Okay, now uh, 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 see V1 uh, which is a root, uh, then this is the left child which is V5. So here I get this uh, left child here V5. Okay. Now V6 is a sibling of V5. V6 is a sibling of V5. So V6 is a right child of V5 here in binary tree, which is a right child of V5 according to our algorithm. Now look at this V3. We have here left child is V7. So for that we can go here V7. This is my V7. Okay. Now again V7 have a sibling V8. Have a sibling V8. So V8 is a right child of V7. Okay, which is a right child of V7. So this is V8. Now, if you look at in V8, then the leftmost is V9. So V9, which is a left child of V8. Left child of V8. Okay, V9 here. Now, this V10 and V11 are sibling of V9. So first left side, first one we get V10, so which is according to binary tree, which is the right child of V9. So we get the right child, this V10 here, and this I call V10. Okay, now, and this is the V11 which is on left hand side, which is sibling of V10, and left hand side of right hand side of V10. So this is also a right child of V10. So we get the right child here of V10. So this is my V11. Okay. Now this is the binary tree which we get from this M-array tree. Okay, and if you look at, see the degree of we are have one child. Okay, not more than two. Okay, similar manner V1 have two child here, V5 and V2. V5 have one child, V6. V2 have one child, V3. V3 have two child here, V7 and V4. V7 have one child, V8. So V8 have one child, V9. V9 have one child, V10, and V10 have one child, V11. So all the like here you get the at most two child here, according to as per our definition of a binary tree. So this is of my our binary tree which we have find out from given tree. So is it clear for everyone? So what this algorithm, how to follow this algorithm? Here the first you have to write down the root of a general tree. Okay, find out the root of general tree, which is also a root of a binary tree. Now then leftmost child of a parent node. Okay, find the leftmost child of a parent node and connect sibling of each node from left to right. Okay, and delete all link from the node to its child, and repeat the same process for all the nodes. So these things we have to do here. We have start with the root of the given M-array tree, which is VR, which is same as the root of a binary tree, and then leftmost child is V1. So we get the left child here, V1. Now these are the siblings, V2, V3, V4, and so we connect from V1 to V2, and which is the right child of this V1. And see, we have deleting all this node V2, V3, and V4 as VR to V2, VR to V3, and VR to V4 here. Okay, so but now V3 is left from V2, right from V2. So V3 is and V3 is sibling of V2. So V3 is a in a binary tree, which is a right child of V2. In similar way, V4 is also a sibling of V3, and which is on right of V3. So V4 is a right child of V3. Now here V1 which have a left child V5 and V6. So similar manner for V1 we get here left child V5. But now V5 and V6 are sibling. So V6 is a right child of V5. And here V3 we have left child V7. So similar manner here V3 we get the left child V7. But now V7 and V8 are sibling. So V8 are the right child, or V8 is the right child of V7. Okay, so we get here right child of V7 is V8. Then you have to look again V8 here the V9, which is the left child, leftmost. So V9 is the leftmost. So here again V9 is the left child we have taken, and these are the siblings. And here V10 is on right on V9 and siblings. So which is a right child of V9. V11, which is a right child of V10. Okay, so in this way you can convert any M-array tree to a binary tree. Okay, and this is a very because representation of binary tree is very easy, and it is easily interpreted. So that's why instead of M-array tree we convert, and both are equivalent. So that's why we convert into a binary tree. So here we have completed our syllabus, and this unit is over here. So there are more than 40 or more than I think 40 definitions we have covered in this unit. So as a definition is a very fundamental start point of any uh, concept. So, and here there are a lot of definitions we have in this unit. So first of all, you must be remember all these definitions. Once you know the definition, you understand the definition, then you can uh, understand the remaining concept or following concept of a on based on definitions. Okay, so it is necessary first all of you to be remember all definitions. Then you can understand the older concept. And here there are a lot of definitions, so it is difficult to be grasped directly or without revise the concept to be cover to grasp at first time any concept. So if you are familiar with once you're familiar with definitions, then you can easily handle or easily you can grasp the concept of this unit. So for my suggestions to for all of you that remember all the definitions and understand all the definitions. And this unit covers a lot of definitions first of all. Okay, so we have done here. So any doubt from your side now? If you have want to understand, like say still we have 10 minutes. So if you want to any doubt or if you have any doubt in this unit, you can ask. No, so still there is no any announcement for our class will be continue on mid 2, but if like possibly like in mid 1, it might be possible your class is not continue during the mid 2. But if it is there any announce, then I will be inform you in your Telegram group and WhatsApp group. Okay, is it clear, Umang? Okay, okay, in Google Classroom. Okay, I will. Okay, but I have already uploaded this PPT on e-content over. Okay. So why you require in Google Classroom even if I have already uploaded e-content? So here I stop the sessions. Okay. So first of all, write down your enrollment number.